طيب اوكي بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. Yes, oh, yes. Also share the screen. Okay, good. Can you see it now? All right. When we have a chemical reaction like this reaction, I told you and I'm repeating, then when you have a chemical reaction like this chemical reaction, you must make sure that it is balanced first, and then and then after balancing it, you should know that this is from the reaction. I did not read even the question or anything. From the reaction, what do I understand? That I need 1 mole of NH4 NO3 to react to decompose to give you what? 1 mole N2O and 2 mole H2O. That is, I did not even give you a question so far. Whenever you see a chemical reaction, you should make sure that it's balanced, and then you can say that I can relate things by what?
By moles.
By mole. That's the most important thing. Now, let's do the question now. Calculate the mass of ammonium nitrate that must be heated in order to produce 10 grams of nitrous oxide. So I want to produce 10 grams of this compound of nitrous oxide, which is this one. How many grams of this one do I need? What's the first thing I should do? 10.0 gram
you can't change the gram into a mole.
I can. How?
By dividing 10 gram over the molar mass.
Exactly. That's the molar mass of N2O. Don't forget that. Nitrogen is 14.01, and then oxygen is 10.02.
It's 44.02.
44.02.
I take your word, okay? And then after that, calculate how many moles. Give me an answer.
Uh, 440.2.
400?
No, 0.2.
0.2.
Must be 0. 0 point what?
227.
227 mole into O, right? How many moles? How many moles of ammonium nitrate I need to make 0.227 mole of N2O?
The same thing. 0.227.
Why is that?
Because 1 mole give you 1 mole.
1 to 1 in the reaction. 1 mole NH4 NO3. Now change this into this. Is this clear?
Yes.
I hope
Yes.
this is clear and obvious. Good. Next. Limiting reactant. I will explain limiting reactant to you in a while, and we will come back to this one. Let's look at this chemical reaction. CO plus 2H2 to give you CH3OH. This is carbon monoxide, and this is hydrogen, and this is a methanol, alcohol, methanol. Good. When you see chemical reaction like this one, what do you understand right away?
Decomposed.
No. What's the relation between the reactant and product?
1 mole give you
1 mole need what?
1 mole from CO and 2 mole from H2.
H2 to give you 1
One
mole.
1 mole.
CH3O.
Is this clear? That's the
Yes.
question. Let's assume that I have 40 gram CO. How many grams of hydrogen do I need to react with it? Do your calculation. Don't forget, what's the mass of CO, by the way? What's the molar mass of CO?
28.01.
And what's the molar mass of hydrogen? H2 molecule.
2 times 1.008.
Exactly. Keep this in mind. All right. And then tell me, if I have 40 grams CO, how many grams H2 do I need to react with it?
2.857.
Let's see.
I'm sorry, doctor, can you repeat the question?
If I have 28.01 gram, oh, sorry, 40 gram CO, how many grams hydrogen?
5.76.
2.85.
2.85.
No.
You have to convert it into a mole.
5.75 gram.
What?
5.75 gram.
Yes, exactly.
Yeah, me too.
I want you, everybody, to do it and make sure that you have the correct answer. The answer is
I have
5.7758 gram, to be exact.
Yes.
Is this clear? So let's make everything even for significant figures, no problem. 40.00 gram CO needs 5.758 gram H2.
Doctor,
Now,
Show us exactly.
can you explain a little bit, please?
again, what?
I didn't get it.
Okay. First, change the 40 grams CO into mole. Can you change it to mole?
Yes, it's 1.42, I think.
1.42 mole? Hello? 1.4
Yes, doctor. It's 1.
mole CO, right?
Yes.
Okay. If I have 1.42 mole CO, how many moles H2 do I need to react with it?
Multiply by 2.
Exactly. What's the answer? 2.84 mole H2. Can you change this into gram?
Yes.
Okay, go ahead. Give the answer.
I will multiply it with 1.008, right?
Yeah, it's the answer. It's 5.7.
Right. You multiply it by this number and you will have the answer. That's it. So 40 grams CO needs 40.00 gram CO need how much? 5.758 gram H2 to make the reaction complete. Is this easy or difficult?
Easy.
Okay.
Easy.
Next, Next, let's assume that I have 40.00 gram CO, and in the lab I mix it. In the lab, I mix 40.00 CO with, oh no, let me, before do that, let me stop here. Before I do that also, let me erase this first. Now, okay. Now, if I have 40 grams CO and 1.42, sorry, and 5.758 gram H2, how many grams CH3 OH I'm going to produce? Grams.
40 grams.
40 grams?
Okay.
Wrong.
No, 1 point.
You have to use mole, don't use anything. You have to know that 1 mole of this one produce how much of this one?
1.
Right?
It's going to be 37.18.
Okay, this means I have to take this number of moles here, 1.42 mole CH3 OH, and change it to gram.
Multiply by the molar mass.
Molar mass, what's the molar mass of this one? You have the carbon, 12.01, hydrogen is 1.008. Of course, I have to multiply this by 4 plus 16. Add them together, you'll find the mass.
The mass is 45.75.
No, cannot be.
32.042.
32.042,
042.
maybe, I believe you. I don't know what is it.
I mean the mass in gram.
The mass, no, okay. No, this is the molar mass. Now change the 142 into mole. Yes, go ahead, give me the answer.
It will be 45.75.
45.75 gram CH3OH. Is this clear? You have to relate things by mole. Okay. Now, yes.
Why we convert 1.42 to gram?
To know how many grams of CH3OH we're going to produce.
We know that 1.4 gram, 42 grams for CO.
There's mole, not gram.
I mean more.
Yeah, that's why I can relate things in mole, because this is 1 to 1. I can say 1 of this one will give me 1 of this one.
Oh, okay.
1 mole will give me 1 mole, and I can relate things by mole, but I cannot relate things by gram.
Doctor,
Yes.
can we just add the mass of the CO and the mass of 2H2?
In this case, because there is the only conservation of mass, everything is reactant to make the product. Okay?
Okay.
Doctor, I multiply 1.42 by 32 by the molar mass by 32.
Yes, exactly. All right, clear? Now, you went to the lab and I gave you 40 grams of CO. Okay? And I mix it with 2 grams hydrogen. All right? I want you to tell me how many grams CH3OH I'm going to produce.
45.75.
What else? Any other suggestion?
Doctor, can you repeat the question?
I repeat the question one more time. You went to the lab, all right? You are in the lab now. We know this. We already did this calculation. Remember this. What I did, I mixed 40 grams of CO with 5.7858 gram of H2 and then I got 45.75 gram CH3OH. This is, we did it from the calculation up. I want you to go to the lab now, and you in the lab you mixed 40 grams CO with 10 grams H2. How many grams of CH3OH you're going to produce?
45.75.
45.75 gram CH3OH will be produced. Why?
Because CO
Because
reacts
40
first.
gram would react with only 5.758.
Okay. In this case, we call the 40 gram limiting reactant. Limiting reactant. ايش معنات limiting؟
محددة.
أنا شفت مرة الحاد بالتفاعل، محدد بالتفاعل. Exactly. It means the reaction will stop. This means in this case, the 40 gram CO will react only with 5.758 gram H2, which is this number. Only. And the rest, what's the difference between 10 and 5.75? Subtract.
4.25.
4 point what?
25.
242 maybe. Yeah. All right. Gram H2. We are going to call this what now? Excess. Excess. What does excess means? Extra.
الفائضة والمتبقي.
Not use. فائض. Extra. Not use. We're going to use only this amount because we know that 1 mole will react with 2 mole, and this is the 2 mole only. It will not react with more than that. And we have this same answer. Is this clear?
Doctor,
Yes.
so the limiting reactant is the substance that fully reacts.
Exactly. Finish.
Okay.
Fully react means finish. We'll finish first.
So, doctor, do we calculate the moles of 40 gram of CO and add it to the
Everything
moles?
you have to change to mole. Everything you have to change to mole. And you have
Yes.
your answer into moles.
I understand, but then do we calculate the moles of 5.758 grams of 2H2
No,
and add them together?
we already did it up here. I got this number from here because I already did it.
Oh, okay.
Okay. Let me give you an example and we will do the same. If I give you this chemical reaction, look at the chemical reaction. What's the relation that you can write?
Three mole.
NaHC.
Of sodium bicarbonate, yes. React with
1 more.
1 more citric acid.
H3C6H.
Citric acid, okay. To give you how many more CO2?
3.
3 more CO2 and
3 mole.
3 more H2O and
1 mole.
1 mole sodium citrate. Sodium citrate. Good. All right. You can relate these things together. The first thing I want you to do, I want you to tell me what's the molar mass of NaHCO3. What's the molar mass? From periodic table. Hello?
75.02.
No, wrong.
84.008.
84.01.
0.
01. Fine. Good. What's the molar mass of citric acid, which is H3C6H5O7? What's the molar mass?
192.12.
Yes.
Gram per mole. Gram per mole. Very good. Okay. Now, you have the reaction. You know the relation. Forget the relation is 3, and here 1. There's nothing written here. What's here? 3, and then here 3 and 1. Don't forget these things. All right? Good. Next. You went to the lab and you mix 1.700 gram of this one, of sodium bicarbonate NaHCO3, sodium bicarbonate. You mix it with 1.000 gram citric acid. I will call it citric acid. Okay? We know the mass of citric acid. I will call it C in this, so to differentiate. Okay? Which one is the limiting reactant? That's my question. What are you going to do?
Convert to moles.
Very good. Convert to mole. Give me answers. I need answers, actually.
Doctor, what's the question again?
Okay. You have the chemical reaction in front of you. Can you see it?
Yeah.
Good. And I also ask you to find the molar mass from the periodic table, the molar mass of sodium bicarbonate and citric acid C.
Yes, good.
C from now on. This is the mass.
Okay.
You went to the lab. Now you are in the lab. And I gave you 1.700 gram sodium carbonate, this number.
Yes.
And I gave you 1 gram of C, which is citric acid.
Yes.
Right? You mixed them together. I want to know, one of them is limiting. Which one is the limiting reactant? Is it the one which is less? Is it 1.000 gram citric acid?
We should convert it to the mole first.
Cannot compare by gram. We have to change it to what?
To moles.
Okay, give me answers for mole.
0.020.
This is mole of what?
NaHCO3.
Okay.
Bicarbonate. Sodium bicarbonate.
You divide 1.7 divide by 84.01. What's the answer?
Yes. It's 0.0202.
0.0203. Right?
Yes.
4.
Very good. Mole. Now I can relate things. mole NaHCO3. Good. How many moles is citric acid?
5.205 times 10 to the power of minus 3.
Just a second. 5.0
5.205
05
times 10 to the power of minus 3.
Who else got the same answer?
Yes.
Yes, I get it.
Yeah, the same, yes.
Great. Now, mole C. Now, I can ask you which one is the limiting reactant?
The second one.
All of you, I want you to think and tell me which one is the limiting reactant, the first one or the second one?
Doctor, the first one, should I multiply by 3 because it's 3 moles?
No, that's what you have in the lab. Don't multiply anything with anything. That's what you have in the lab. You should see how much of this one need from this one. If I have 5.205 times 10 to the power minus 3 mole C, how much do I need of this one? Now I multiply this number by 3 to
By
know
3.
which is, what's the answer?
Zero point 0.0156.
0.0156.
0.0156.
Anybody got the same answer?
Yes, yeah.
Mole needed. This means 5.205 times 10 to the power minus 3 of citric acid needs 0.0156 mole of NaHCO3. How much will be excess?
.6 times 10 to the power minus 3.
4.6. What?
Times 10 to the power of...
Give me one number. 4.6 what?
3.
3 mole. What's this?
The
Axis.
Excess. Don't forget this, excess. All right. Can you change it to gram?
Doctor, sorry, what does excess mean?
Extra. زايد. ما حيتفاعل.
0.388.
89.
Again, repeat.
0.389.
89 extra. Are you following?
Yes.
I repeat one more time. Lab. I am in the lab now. I mix this one with this one. I want to know how the reaction is going to go. I convert the gram into mole. After I convert it into mole, I found which one is the less amount needed. And I found that citric acid needs only 0.0156, while what I have is 0.02023 mole sodium bicarbonate. So that's what will be needed to make the reaction complete. And the rest, the difference between this one minus this one will be extra or excess. If you subtract the first one, 0.02 from 0.0156, you will get this one as excess, not used, and I changed it to gram.
Doctor, how do you calculate
Doctor, to get
0.56?
the most needed, we divide.
We divide what?
The moles needed in the equation. We divide, right?
No, not divide.
To calculate it.
If we
The
subtract
0.0156.
1 from 2, okay? 1 minus 2 will give you the excess that is not used. Did you understand it?
Yes, yes.
Because, see, that's what I have in the lab. 1.7. I change it to mole. And then I change also this 1 gram into mole. I know this amount, which is 5.2405 of citric acid times 10 to the power minus 3, need only 0.0156. From where did I get this number? I multiplied this number by 3. This number, which is 5.25, I multiplied by 3. Why did I multiply it by 3?
The number of moles.
Because it's 3 to 1. 3 to 1. So what I need is 0.0156 mole needed from sodium bicarbonate. And now the rest will be not used. So the difference between 1 and 2 will not be used. This will be excess mole. I change it into gram by multiplying this number by 84.01. That's it.
دكتور
Yes.
بعد ما نقصنا كيف عرفنا العنصر النتج اللي هو NaHCO3 أو H3C6؟
ما نتج شيء. احنا قاعدين نراقب ارقام بس ما
بعدين
ولا شيء.
لما بنحول لجرام بنضرب في أي اللي هو في شو اسمه الأول ولا الثاني من شو اسمه؟
انت مع مين تتعامل الان؟
مع المولات.
which مولات حق اي مركب؟
حق ال NaHCO3 وال H3C6.
طيب هذا المولز اللي كان عندنا اصلا، وهذا المولز اللي استخدمناه في التفاعل، وهذا ايش هذا؟
هذا الديفرنس بين
الديفرنس بين الموجود والمستخدم.
صحيح صحيح.
هذا تقدر تحول هذا الى جرام؟
ايه
تضربه في اي واحد، في ال 84 ولا 192؟
في الموجود
اي واحد
اللي هو ال 84.
why 84 not 192؟
لأنه هو المستخدم
هو اللي احنا نتكلم عنه كله طول الوقت، اللي هو هذا. صح
صح.
اوكي now إذا كان عندي هنا this one is what I need from, I mean how many moles I need from this one or available? 5.205 times 10 to the power minus 3 of this one. How many moles of sodium bicarbonate do I need? Yes?
Two, 0, 2, 3.
No, I need 0.0156 to react with it. That's what will react with it. There is extra amount that will not be used. Now, if I react this 1 mole with this 1 mole, how many moles CO2 I'm going to produce?
Three moles.
No, not 3 moles.
Could you repeat that?
If I put this one with this one, how many moles CO2 I'm going to make?
0.0156.
0.0156 mole CO2. How many moles water?
Same. 0.0156.
56 moles H2O. How many moles sodium citrate?
5.205 5
times 10 to the power minus 3.
Doctor,
Clear?
doctor,
Yes.
if there is no exceed the substance, does that mean there is no limiting substance?
Yeah,
Okay.
of course. طبعا if there is no limiting معناته ما في excess.
Doctor, how did you know
Doctor.
that 0.0156 is needed?
Because of the equation. The equation here, 3 will give you 3. 0.0156 will give you 0.0156. صح?
No, I mean in the beginning.
That's what we calculate. This is the calculation.
So after calculation.
Yeah.
Okay.
We calculate from this one. We can change the mole. After change the mole, we wanted to know how much of sodium bicarbonate. I multiply this by 3 because I know 3 moles needed for each 1 mole. If I have 5.205 times 10 to the power minus 3 mole of this one, I need to multiply this by 3 to make 0.156.
Okay, clear. Thank you.
Okay, good. How many grams CO2 will be produced?
Okay.
2.059.
2.059. Anybody got the same answer?
Zero. How much, doctor?
Wrong. How many grams wrong did I have?
I got 0.686.
Yeah, me
Yusuf,
too.
Yes.
0.686.
Me too.
That's the wrong answer here.
Doctor, did we say that I'll get 0.0156 modes because it's multiplied by 3 and sodium polychloride is multiplied by 3 too?
Repeat your question.
The sodium bicarbonate now is multiplied by 3 moles, right?
Yes.
That's 0.156 mole.
Yes.
Did we say that CO2 would have 0.0156 moles because it's multiplied by 3 too?
Of course, because it's 3 to 3. 3
Okay.
mole of this one will give you 3 mole of this one. Or 0.156 of this one will give you 0.156.
Okay, but what if I have in the product a formula multiplied by 2 moles?
No. Just a second. Let's concentrate on this one. If I have 0.0156 mole of sodium bicarbonate, how many moles of sodium citrate I'm going to produce? This is now 3 to 1. This is 3 and this is 1. How many moles of this one? Concentrate on this one.
We'll divide by 3?
Yes, you have to divide this number by 3. And this will give you 5.205 times 10 to the power minus 3.
Okay.
Got it?
Yeah, I get it.
All right. I hope so. So let's see. So the mass of or the axis is 0.389. Let's see if the axis is 3.88. The axis and the 3.388. 3.89. Yeah, okay. We got 3.89 and the correct answer is 3.388. And the amount of CO2 produced is 0.686. 6.867 actually produced, which is okay. So, okay. All right. Okay. With this, I'll stop here. Let's go now to the attendance. Okay, let me first stop recording.